Hello, this is Brother Cromar from the Math Department at BYU Idaho, and this is a continuation of videos dealing with describing categorical data, proportions, and sampling distribution of a sample proportion. So this is the second part. We're primarily focusing in on finding probability for distribution of sample proportions. So let's review what we covered going back to Unit 1, dealing with distribution of sample means. So here's an example with this. The length of human pregnancy from conception to birth is normally distributed with the mean of 266 days and a standard deviation of 16 days. Suppose a random sample of 30 pregnancies was measured. What is the mean, standard deviation, and shape of the distribution of sample mean pregnancies based on a sample of 30? Well, the mean of the sample means is equal to the population mean, which in this case is 266 days. The standard deviation of the distribution of sample means is the original standard deviation, or the standard deviation from the current population, divided by the square root of our sample size, which is 16 divided by the square root of 30, so we get a number of 2.92 days. And the shape of this distribution of sample means is normal, since the parent population is normal. Regardless of the sample size, we have a sample size of 30. Since the parent population is normal, the shape, the distribution of sample means is also normal. Now we can also find area, going back to finding area under a distribution of sample means curve or distribution. We can go through this example similarly to what we've seen from the last page here. We can go through it finding the z-score and getting a probability. So going back to this problem where the mean is 266 days, the standard deviation of 16 days, what is the probability that a random sample of 30 pregnancies have a mean pregnancy period less than 260 days? Okay. So first of all, we convert the value of x bar using a standard normal variable z, find the z-score. So we take the 260, we get the z-score for 260, where we take the 260, that's x bar, minus our population mean, which is 266, divided by our standard deviation, our population standard deviation, which is 16, over the square root of our sample size, which is 30. We solve for this and we get a z-score of negative 2.050. So we take that z-score, we plug it into our applet, and here's an example what you see down here of the applet. I put in the negative 2.050. We're shading to the left because we're looking for the probability less than 260. We shade to the left and we get an area which is 0.0202. So that's the probability of that a random sample of 30 pregnancies has a mean pregnancy period less than 260 days. Now we can take this and apply this to the sampling distribution of proportions. And here's an example of this. A nationwide survey indicated that about 80%, or P, that's our population proportion of college students with cell phones, send and receive text messages with their phones. Suppose a simple random sample of 200 college students with cell phones is obtained. What is the mean and standard deviation and shape of the distribution of sample proportions based on a sample of 200 students? Okay. So first of all, the mean of the distribution of sample proportions is equal to the population proportion, which in this case is 80% or 0.80. The standard deviation of our sample proportions is the square root of the population proportion times, in parentheses, 1 minus the population proportion over our sample size, which is n. So in this case, p is 0.8, so we take 0.8 times 1 minus 0.8, and we divide it by 200, and we take the square root of that, and we get our standard deviation of 0.028 or 2.8%, whether it's in decimal form or percentage form. The shape is normal since n times p is greater than 10, and n times 1 minus p is also greater than 10. So if we took our sample size, which is 200, times p, which is 0.8, that's definitely beyond 10. So our requirement is met there. And since 200 times 1 minus p, which would be 0.20 in this case, that would also be above 10 as well. So our requirement is met to assume that the shape is normally distributed. So now what we can do is we can, given the shape, going back to this, given the center, the spread, and the shape of the distribution of sample proportions, then we can deal with the problem, finding area under the curve. A nationwide study indicated that about 80% of college students with cell phones send and receive text messages with their phones. What is the probability that 172 or 86% or less college students in the sample of 200 send and receive text messages with their cell phones? So there's two steps, like we see. If I go back a couple of slides here, there's two steps. We convert to z-score, convert x bar to z-score, and then we get our probability. We do the same thing here, but we convert p hat to a z-score, and then we go to the output to get our probability. So here we take the 86%, or 0.86, minus our population proportion, which is 0.8, divided by our standard deviation, and our standard deviation is the square root of p times 1 minus p over n. In this case, it's 0.8 times 1 minus 0.8 divided by 200, and that's all square rooted. We get a z-score of 2.12. So now what we do is we take this 2.12, put it into the applet, but here we shade to the left because we're dealing with less, 186% or less, so we shade to the left of 2.12 to get a probability of 0.983. Okay, let's go through one more example. Here's a problem where the true proportion of people who support a particular political candidate is 0.48. If n is equal to 1,041 people are surveyed, what is the mean and standard deviation shape of the distribution of sample proportions? So what you can do is stop the video and determine the mean, the standard deviation, and shape of the distribution of sample proportions. Okay? So p, or the mean of the distribution of p hat, is equal to our population proportion, which is 0.48. Our standard deviation of our sample proportions is the square root of p times 1 minus p over n. So that's 0.48 times 1 minus 0.48 divided by 1,041, and it's square rooted. So we get a standard deviation of 0.015 or 1.5%. And then the shape is normal, since if we take 1,041 times 0.48, that's well beyond 10. And 1,041 times 1 minus 0.48, that's also well beyond 10, so the shape is normally distributed. Okay? So let's go through this problem here, dealing with area under the distribution of the sample proportion. If the true proportion of people who support a particular political candidate is 0.48, and if n is equal to 1,041 people are surveyed, what is the probability that the results of the survey will suggest that the candidate will win the election? So stop the video and see if you can do the two steps. Okay. Now the two steps, this is really step 1 and this is step 2. Step 1 is convert the standardized value of p hat using the standard normal variable z. But what is p hat in this case? We're looking to see what's the probability that the results of the survey suggest that the candidate will win the election. What's the percentage it needs to be above for a candidate to win? Well, it's 50%. So we're going to use 50% of 0.5 to get the z-score. So it's 0.5 minus 0.48 divided by the standard deviation, which is 0.48 times 1 minus 0.48 divided by 1,041, and that's all square rooted. And we get a z-score of 1.292. So then the next thing is find the area under the curve. So we're looking for the probability that the results of the survey will suggest that the candidate will win the election. So then what we can do is we take this 1.92, and then we shade the 1.292, we put that into our applet, and we shade to the right, because we're looking for the probability of the results of the survey will suggest the candidate won the election. So we're looking to see if it's above 50%. If the sampling need to be above 50%. And so if we do that, we get a result here in our applet, which is 0.0982. And that's the probability, given that the population proportion is 0.48. That's the probability of getting a sample with a sample size of 1,041 of a sample determining the results of the survey will suggest the candidate will win the election. Okay? And that concludes the videos dealing with, and I'll get back to it, dealing with describing categorical data, proportions, and sampling distributions of the sample proportion. If you have any questions, please speak to your instructor or to one of your TAs.